This is pre-calculus, notes on 5.4, graphs of exponential and logarithmic functions. All right, guys, the good news here is that you don't actually have to graph these functions. However, you do need to know some properties of them. You should be familiar with seeing them. You will be expected to describe the domain of both functions and the range of both functions. And you will be expected to describe transformations of them. All right, so I'm just going to talk you through some of the key points first of all. We're going to start with the graph y equals e to the power of x. I also want to explain again that the function, the natural log of x, is the inverse function to e to the power of x. And one thing that you should understand is that all inverse functions are reflections of each other across the line y equals x. So if you were to take any point on the blue graph, that's e to the power of x, and reflect it across that green dotted line, you get a point on the red graph, okay? That's a property of any inverse function. The next thing I want to talk about are the asymptotes, okay? So the function that's in blue, y equals e to the x, okay? There is a horizontal asymptote. You're going to negative infinity. So as x gets smaller and smaller and smaller and smaller and smaller, as x goes to the left, y gets closer to 0. Okay, that's what's happening there. And if that's what happens in the function e to the power of x, its inverse function has to have a vertical asymptote. Okay, so as x is getting closer to 0, y is getting closer to negative infinity. All right. So those are those asymptotes. All right, let's talk about domain and range. Okay. All right, so let's again think about the function e to the power of x. So what values can I plug into x in that function? Well, I could, an exponent can be any number. It can be positive, it can be negative, it can be 0. There are no restrictions on that domain. So the domain of the exponential function, the domain is all real numbers. The range is the y values. Okay, well, let's look again at the graph. Okay, so y can never be negative. The entire blue graph is on the top half. It is never a negative number because e is positive. No matter what power you raise it to, the answer will always be positive. So the range is all positive numbers. All right, well, what does that tell you about the inverse? Well, the inverse function flips the domain with the range. So the input becomes everything that the output was in the other graph. All right, so the domain is all real numbers. The domain is all positive numbers. It can only be positive, and the range is all real numbers. Okay. All right, let's take a look at also these reference points down here. Okay, let's take a look at, first of all, the function f of x is 10 to the power of something. And let's just think about putting these values in for x and what would their y's be. You should be able to generate these points by yourself. You don't have to memorize them because 10 to the power of -1, okay, any negative is just a fraction, right? So, or the reciprocal. So 10 to the power of -1, you put a -1 in, the y is 1/10. 10 to the power of 0, well, anything to the power of 0 is 1, so 0, 1 lies on that graph. Well, what's 10 to the power of 1? 10 to the power of 1 is 10, so you should be able to generate that graph very easily, okay? Well, if that's the case, remember, an inverse function, you just flip x's and y's. So the x-coordinate becomes the y-coordinate becomes the x. So whenever you're trying to do logarithmic, think about what the some points on the exponential graph, flip them backwards to get points for the logarithmic graph. All right, let's talk a little bit about, what's next? About the transformations, okay? So in chapter 3, we did transformations of some other parent graphs. Now we're just going to talk about the same transformations, all the same rules apply. You're really only concerned, though, with vertical and horizontal shifts for this course this year, okay? So C is going to move left and right. D is going to move up and down. Okay, describe the transformation, give the domain and range of the function. Okay, so for problem 19, okay, since this is inside the parentheses, this is a horizontal shift. It is going to shift to the right. Okay. All right, let's think about the graph. Here's the parent graph. Right? So if I were to now shift that to the right here, okay, so instead of having a vertical asymptote on the y-axis, it's now going to have a vertical asymptote at x equals 4. Okay? So the domain is not going to be all positive numbers anymore. The domain is going to be x is greater than 4. Okay? The range is still all real numbers. All right, problem 20, okay? This is a shift left 3. And shift down 4. Okay, let's draw it. And again, here's the paragraph. And then it's going to move to the left 3. So the vertical asymptote is going to be here. Okay, and then it's going to move down 4. So let me think about this. So the point that was at 0, 1, right here. I should be looking at the red graph. Okay, so the point that is here, okay, at 1, 0, is now going to go to negative 4, 0. All right, so I've got 4. I should have said 0, negative 4. So that is going to be here. All right, one more time. That point that is at 1, 0, okay, let me think about that. 1, 0 is moving to the left 3 and down 4. So it's going to be 1 subtract 3, it's going to go to negative 2, negative 4. It's going to left 3 and down 4. So that's 1, 2, and then down here. All right, so it's going through this point. It has a vertical asymptote at negative 3. Okay. All right, anyway, the domain, that's what I'm trying to get at. The domain, all right, well, it has to only be numbers bigger than negative 3. The domain are only numbers that are bigger than negative 3. The range is all real numbers. And so exactly where that point went through is really not all that important. I'm sorry I stuttered on that question, but what is most important is this vertical asymptote. This graph will never cross the line x equals -3. All right, that's it for that.